with we will continue with multiplexer and demultiplexer. Remember yesterday we have share on decoder and encoder, and how actually priority encoder is given the highest input, okay, is given the priority to be output, okay. Tidak kira what is the how many inputs are active at that particular instant, but the highest input will be, the value of the highest input will be output for an encode, for a priority encoder. In addition to that, we have also looked into the types of integrated circuits, yeah, yang mana most of it depends on enables, or on the enable inputs for it to actually be enable input. So just share balik sikit ya. The enable inputs ya situ on how actually it is being used to activate the IC ya, and juga the usage of decoder as a to implement combinational logic circuits seperti yang sini tadi. Sini, okay, decoder juga boleh digunakan to implement logic circuits ya. So today we will go into multiplexer and we will see what is multiplexer and demultiplexer is all about. Okay, so the symbol of multiplexer is here, MUX. Okay, multiplexer is actually like a switch. It acts like a digital switches that will connect the input, okay, from one source to the output. Okay, one additional things about multiplexer, it has one more, which is the select switch. Okay, it has inputs, okay, the number of inputs, it has one output, okay, and it also has enable for it for the circuit to be activated as a multiplexer, and it has select switch to inform which inputs, okay, to be sent to the output. Okay, so itu yang kita kena tahu about multiplexer. It has another one which is the select switch. Okay, so if from the name ya, multiplexer, it has only one output. You have to remember that. Okay, kalau decoder 3 to 8 decoder, that represents 3 inputs and 8 outputs. So how do we know 8 outputs? Is from the 3 inputs, 2 to the power of 3, we have 8 outputs, 8 possible outputs. Even though we have 8 outputs, only one will be active at one particular instant. And which output to be activated or active, that depends on what is the inputs of the decoder at that particular time. Okay. Okay, and the other one is encoder. Okay, so if we have 8 to 3 encoder, 4 to 2 encoder, okay, so from the name, kita tahulah berapa bilangan input encoder dan berapa output yang dia ada ya. Okay. Now, multiplexer, it has only one output. But even though which output to be sent, that depends to the select switch. Okay, so S1, S0 ni adalah select switchnya. Input 0, input 1, input 2, input 3, sorry, that is the inputs. And Y is the output. Okay. So select switch will determine which input will be sent to the output. So if we have 4 inputs, so select switch dia adalah 2 to the power of 2 is equal to 4, because kita nak select switch to be able to actually input to select all the possible inputs, okay, to be sent to the output ya. Ni select switch ni bawah ni. S1, S0, these are the various symbols of multiplexer. Okay, 4 to 1 marks. Maknanya dia ada 4 inputs. Of course, multiplexer dia ada 1 output only. But we need to know berapa select switch dia ada. That depends on the number of inputs. So 2 to the power of n is equal to 4, where 4 is number of inputs. So select switch will be 2. 2 to the power of n is 2 in this case. So kalau dia ada 8 inputs, multiplexer yang 8 inputs, 2 to the power of n is equal to 8. So select switch dia kena ada 3. Okay, so there are 3 select switch. Okay, so which inputs is to be sent to the output, that depends on this combination of select switch, ya. So bila 0 0, when the select switch is 0 0, output will receive input 0 to be sent to the output. So in this case, input 0 is D naught lah. So outputnya akan menerima D naught. Whatever the D naught is, whatever the value of D naught, sama ada 0 atau 1. Okay, seterusnya, okay, 0 1 output, the Y output will receive input 1, input 2, 1 0, dan masa 2 2 high adalah input 3. So what is the value of input 0, input 1, input 2, input 3? That depends on what are the values here to be sent to the respective output based on the selection of the select lines. Okay. Okay, these are the circuits of 4-to-1 mux. 4-to-1 multiplexer, these are the select line. Dia menggunakan decoder sebagai select line dia. Dan apa nilai select line pada ketika itu, katakan if it is 0 0, we know that input 0 will be sent to output Y, dan seterusnya. Okay, ini dari segi circuit, ini dari segi logic symbol, ini truth table-nya, ini truth table select line. So this is another representative of a 4-to-1 multiplexer. Okay, so what if actually di sini we throw a questions, yeah. By now we have understand that if it's a single bit data that is selected by the multiplexer, what if we want to select a certain number of bit data or words? In that case, we need to combine the multiplexer in blocks in parallel, ya. Dan kita commonkan select line dan enable signal dia tu. Macam kita buat untuk kita punya decoder semalam, ya. For our decoder yesterday we have seen that, yeah, here. If we want a 2 to 4 decoder to function as a 3 to 8 decoder, one of the choice is we combine 2 to 4 decoders and kita commonkan inputsnya, dan enable will be the third input. Okay, which is the most significant bit. Okay, similarly here, okay, for our multiplexer, if we have more than 1 bit kat sini, okay, what we will do is we will combine we will combine several multiplexer in blocks, and kita select and enable seperti the decoder punya example that we have actually examined yesterday. Okay, these are one of the solutions, okay, yang kita share di sini. Sorry. Quad for 2-to-1 mux. Okay, di sini kita menggunakan kita use 4-to-1 multiplexer, di mana kita commonkan all the select line dan the enable, so that it becomes 16 to 4 multiplexer, ya. Ini kita ambil the first 8 di situ, yang nanti dia ada dekat bawah lagi di situ, ya. Okay. So select line will choose between A and B, okay, for these 4 wire signals, okay. So this one kita ada di sini, and enable line dia adalah select di sini, dan juga yang enable ni one more. So we have one yang sini yang di-commonkan, and then enable will be the other one to become the select line. Okay. Okay, selain daripada tu, okay, multiplexer is also can also be used to implement Boolean function similar to decoder. So how can we actually implement that? Okay, is one example here. Let's say you have you want to implement this, yeah, min term 1, 2, 6, and 7. Okay, so one way to implement is you simplify it using Boolean algebra, which we have seen last 2 weeks. Selain daripada itu, you boleh gunakan K-map juga. Selain daripada itu, you boleh gunakan decoder. Okay, another way you can use multiplexer, okay, to implement this logic circuit given min term 1, 2, 6, 7. So how do we do that? Okay, look at this. X, Y, Z, okay, 3 inputs. We will have 8 possible input combination. By now you should know already, yeah. Okay, kalau ada 3 inputs, ada berapa possible input output combination, berapa output combination dan sebagainya. Okay. So, kalau you tengok di sini ya, X, Y, Z 0, 0, 0, 0, 0, 1, the first two, the output is 0 and 1. So, you ambil F sebagai Z. Why Z? Because kalau you tengok Z tu adalah 1. Okay. Output F tu adalah 1 dan masa 1 tu Z adalah 1. Sini. This one. So F is Z. Yeah, the second one F, the output is Z bar. Why Z bar? Sebab output 1 ketika Z adalah 0. So it's Z bar. Kita ambil mana Z yang satu saja. Iaitu pada minterm 1, 2, 6, 7. Okay. Masa 6, okay, 110, bottom here, 110 ya, and 111, masa 7, okay. Masa 6 and 7, kita ambil dia sebagai 1, F is 1. Why 1? Because Z adalah Z bar or Z. So Z bar or Z will give us a 1. Remember the Boolean algebra. Okay, so from there, okay, remember this is 4 to 1 multiplexer ya. So this is the select line. X and Y ni akan jadi select line. 0, 0, 0, 1. Ni dua ni. 0, 0, 0, 1. 1, 0, 1, 1. Okay. So X, Y tu menjadi, kita letakkan di select line. Dan the four inputs of the multiplexer, remember this is 4 to 1 marks adalah the output of F. Yang kita set sebagai Z, Z bar, 0 and 1. This is one way how you can implement multiplexer sebagai logic implementation. Okay, I guess yang ini selalu student macam akan a little bit confused. Is there any question from your side on this one? Sila. Okay, remember ya, X, Y ni adalah daripada select line because it is represented by 0, 0, 0, 1, 1, 0, 1, 1. So, itu select line. While the 4 inputs, remember this is 4 to 1 multiplexer, the 4 inputs kita setkan untuk Z. How do we set nilai Z ni? That depends on the minterm given to us. Okay. And when select line is 0, 0, output yang keluar adalah Z. Bila 0, 1, output yang keluar will be Z bar. It depends what is the value that kita set here. We set it here. When it's 1, 0, when select line is 1, 0, the output will be 0. And when it is 1, 1, the output will be 1. So output sini, input dekat multiplexer ni 0, 0, 0, 1, 1, 0, 1, 1 ni, okay, based on the select line, that is what we set here. Why we set is as such? Because this is the minterm given to us. Okay? Boleh? One minute ya. Boleh? Okay, tak apa, nanti kalau dah ada dah pun arrows-nya di situ. Sorry. Okay. Okay. So that is how the implementation of multiplexer untuk logic circuits ya, to execute the logic expressions given in terms of minterm. Okay. Okay. So ada banyak cara that we can implement logic implementation or logic circuits ya. So selalunya in questions lah, they will specify very maybe in a design question they would not specify exactly which method to use. Maybe if it's going to be Boolean or K-map or decoder or multiplexer. Okay. Then you can select which one that you understand the most. But at this level, we as students, yeah, we need to understand everything, yeah, because at least That's how actually we equip ourselves, okay, untuk kita go for the solution. Okay, we cannot choose, okay, I want to study this one, not this one. No, we have to understand everything. Yeah, because that is the how to know how robust or the best method that you can select among the 4 that is actually taught to you. Yeah. Okay, so untuk implement multiplexes sebagai Boolean function, okay, so the tips the tips that you need to know, the first thing you need to know what is the number of variables of that Boolean function. Kalau 4 variables, select line dia bergantung kepada 2 ganda n bersamaan dengan 4. So di situ select line perlu ada 2. Itu satu tips yang you kena tahu. And then dekat select lines tu, okay, dekat select line tu you ambil the most significant bit. Contohnya di sini. X, Y, Z. Okay, X and Y adalah the 2 most significant bit. So itu berada di select line, ya. 00, 01, 10, 11. That is the second one. Okay, and then the third one, attach the most significant n minus y variables to the n minus 1 select lines. And then dia punya least significant variable tu dalam case yang kita tengok tadi adalah z, okay. Itu you tengok nanti kesesuaian outputnya and set the input of your multiplexer so that it corresponds to your output that you require. Okay, and then seterusnya that is how the implementation is done. Okay, I want you to try this. Consider FABC 1356, implement using a 4-to-1 multiplexer. Okay, and then dapatkan truth table dia and draw the circuit. Cuba sekarang boleh? Because if you don't try, we don't know whether you understand or not. Sila. Cuba sekarang and I will share with you the answer. Mahasiswa, mahasiswi boleh cuba sekarang. Saya bagi 5 minit untuk cuba ya. Okay, have you tried? Okay, this is the answer. Okay, we are given min term 1, 3, 5 and 6. Okay, so dekat 1, 3, 5 and 6. Okay, that's the truth table. Okay, and when A is B, A dengan B is 0. Okay, kita dapat F dia C, which is 1 here. So 0, 1, 2, 2 sini. Ini semua select line punya ya. Okay. Okay, and then F is C and F is C bar. That's how the di situ. And then sorry, here. That's how the truth table akan kita assign. Okay. And if you are settled with the truth table, the circuit for it is as such. Ya, ada apa-apa soalan untuk soalan yang ni? Boleh? Everyone? Okay. Oh, begini pun boleh. Ada several ways. Kalau kita buat macam ni boleh. Ya, using this logic symbol. Okay. Okay, another example. Okay, this is actually 8-to-1 multiplexer. Okay. Dan ini diberi kepada kita truth table and we determine the output of D. Okay. So D adalah D min term 1, 3, 4, 11, 12, 13, 14, 15. Kan? Okay. And in this case, the first three most significant bit akan menjadi select line, which is A, B, and C. Okay. Dan D adalah the least significant bit yang kita akan aturkan. We will arrange the inputs of this 8 multiplexer. Okay, that depends on what is the value here. So when it is 0, 0, 0, remember ini sekarang 4 tau. When it is 0, 0, 0, kita ada 3 select line di situ. F is equal to D. Sebab bila 1 ni, it's D dia 1. So di sini kita letak D. When it is 0, 0, 1, again F is equal to D. When it's 0, 1, 0, F is equal to D bar. Sebab sini adalah 1. D dia D bar. So kita invert dari sini. Dan seterusnya. When it is 0, 1, 1, F is 0 sebab dua-dua 0 di sini. 1, 0, 0, also 0. 1, 0, 1, F is D again. 1, 0, 1 dekat 5 ya. So dia jadi D again. 1, 1, 0, it is 1. Dua-dua ni 1, F is 1. And also 1, 1, 1, sini, F is 1. That's how we arrange. Ya. So kalau kita guna multiplexer ni sebenarnya, sorry. The number of logic gates required adalah very minimal. Okay? And the design lebih compact lah. Okay, using multiplexer to implement logic circuits. Yeah. Okay, so another thing that we found out is actually multiplexer juga adalah universal gate, yeah, because we can use multiplexer untuk replace our normal logic gates. Okay, so 2-to-1 multiplexer also is known as a universal gate. So how is that being implemented? Okay, kalau 2-to-1 multiplexer sebagai OR gate, remember OR gate. Okay, OR gate maknanya kalau input 0, okay, outputnya 0. Saat any of the input 1, the output will be high. Okay, so ini. Okay, sebagai NOT gate juga kita invert dan sebagai AND gate. Okay, this is multiplexer as a universal gate. Okay, larger multiplexer. Okay, macam maknanya bagaimana kita nak implement 8-to-1 multiplexer menggunakan several 4-to-1 multiplexer. So, if we want it to function as 8, sekejap saya nak turunkan ni sikit sebab dia macam ke okay. Dia macam ganggu. Okay. So if we want to actually implement 8-to-1 multiplexer, okay, using 4-to-1 multiplexer, this is the way actually. Di mana, of course we need we need two 4-to-1 multiplexer because they ada 8 inputs kan. So that settle this part. So from that two, okay, from that two outputs of the first upper marks and the lower marks, kita masukkan kepada 2-to-1 multiplexer, so it produce a 1 output. Okay, and the select line kalau 8 multiplexer, we will have 2 to the power of n is equal to 8 inputs, so we need 3 select line. So the select line adalah S2 from here, and untuk this 2 kita common kan, S1 and S0. So those are the 3 select lines, which is S2, S1, S0, to actually control which inputs to be sent to the output. That is going to give us the 8 possible outputs of our multiplexer. Okay, ini adalah how to implement larger multiplexer menggunakan two possible 4-to-1 multiplexer. Any question before we proceed? How many of you online? 56. Okay. Okay. Okay, this is actually 16-to-1. 16-to-1 multiplexer, kita gunakan 4-to-1 multiplexer, di mana the first 4, 1, 2, 3, 4 is for to handle the 16 inputs, and another 4-to-1 multiplexer is for the output here. So kalau 16 inputs, we need 2 to the power of n is equal to 16, so we need n must be 4. So we need 4 select lines. So the 4 select line will be di sini, S3, S2, dan S1, S0. Okay. This is actually some IC on multiplexers. Okay. You don't have to actually hafal the number, but you need to understand the truth table and the data sheet of this IC, especially when we want to use it during our design or project design dan sebagainya. Okay, that's about multiplexer. Any question before we go to, wait, I will just stop share. Before we go to D multiplexer. Any question, mahasiswa? Okay, thank you. Okay, we will proceed. Thank you, Omar, for the response. So, kita proceed ya. Sebentar. Okay, here. Okay, let's look at demultiplexer. Okay. Okay, demultiplexer, okay, it is doing the opposite of our multiplexer. Okay, it has select line as well, yeah. Okay, and it is actually using n to 2 to the power of n binary decoders. It is something like decoder as well, except dia ada select line here. Okay, where the decoders enable line is used for data input of the demux. Okay, so that is the demultiplexer. Okay, so we will have dia opposite of kita punya multiplexer. So it has 1 to 4 demux. Okay, which means okay, dia ada one input that depends on the select line. Okay, and which output to be activated. Okay. Okay, that depends on which select line is apa ni, select line punya value. Well, now you tengok ni demux ni, sorry. You tengok demux ni dengan 2 to 4 decoder. It is almost similar. Okay, cumanya select line di multiplexer ni adalah seperti input of the 2 to 4 decoder. And then it has 4 outputs, yes, but only one will be activated at one particular time. Okay, so you can understand demultiplexer ini adalah similar to our decoder. Well, and the input data satu ni adalah seperti enable di decoder tersebut. Okay, so kalau untuk demultiplexer, when it is 0, 0, okay, so output 0 will be active, which is why not di sini, ya. Dan output lain adalah disable. Seterusnya bila 0, 1, output 1 will active dan selainnya adalah disable. Okay. Dan seterusnya 1, 0, output 2 dan 1, 1, output 3. Remember, like decoder juga, even though it has several outputs, but only one can be activated at one particular time. Okay, so I think di multiplexer ni akan adalah lebih mudah untuk kita faham, ya. So multiplexer and demultiplexer application example, satu adalah in communication system lah, ya, di mana selalunya kita ada several sources and we want to send one at one particular instance daripada source kepada destination. Okay, dan apabila sampai kat destination tu, okay, kita disperse the information, ya. Ini satu contoh. Okay, that is about the multiplexer. Now we are going to digital to analog converter. Macam mana? Okay, the multiplexer so far, so that we can actually proceed to analog to digital converter. Okay. Okay, if it's okay, I will proceed with the AC sebentar, ya. Okay. Okay. So, when do we require this analog to digital converter and digital to analog converter, ya? So, the nature of the signals around us are as such. We have analog, okay, so we need the digital to analog converter to convert it to binary and vice versa. Okay, so for analog to digital converter, okay, we need to the signal that we receive, okay, is in analog form and we would like to convert it to digital, dan kemudian bila kita nak guna balik from digital, we convert back to analog, ya. So sebentar, dia macam bergerak sikit. Okay. Okay, so digital analog conversion, okay, is actually a process where we receive a binary code and this is the circuit. Ada dua circuit yang kita akan tengok today that can perform digital to analog conversion that will convert it to analog signal. Okay, so selalunya kita akan ada reference voltage that we use to determine the full scale output of our digital to analog conversions. Okay, and dan untuk contoh ini kita akan menggunakan sebagai contoh adalah untuk 4-bit DAC. Okay, silap ni. Okay, 4-bit DAC. Okay, let's look at the first one. Ini adalah contoh. If we have a 4-bit digital inputs, okay, that we would like to convert it to analog, okay, and the reference voltage is 16. Okay, the first thing that we need to know is which one is the most significant bit. We need to know that which is the most significant bit. Okay, so if we have 4 inputs, it will give us 16 possible outputs ya. Ini semua tahu kan, 16 possible inputs combination dan 16 possible outputs. Okay, okay, so setiap value tu dia ada unique value dia, maknanya berapa step size dia. Kita kena tahu berapa step size yang kita akan gunakan untuk conversion from 0000001 sehingga 1111. Okay, supaya dia adalah the step size is consistent from one value to another. Okay, so that is how actually kita dapatkan the step size. The first thing kalau untuk digital to analog converter, we need to know what is the step size, or else kita tidak akan ada yang consistent. Okay, so for this particular example, for this particular contoh ya, kita akan tengok di sini satu contoh example di sini. Okay, a 5-bit digital to analog conversion has a current output. For a digital input of 10100, an output current of 10 milliamp is produced. What will be I out for digital input of 11101? Kalau saya tak bawa pula board saya hari ni balik. Okay, so it will be a 5 bits, 1, 2, 3, 4, 5, 6 ya. Ini 6 bits lah. So kalau 5 bit, you akan ada start daripada 2 to the power of 0, kan? You akan ada R, 2R, okay, 4R, 8R and 16R. You will have until 16R. Okay, untuk 5 bit ni. Okay, so yang ini kita kena buat sama-sama lah. This example, let's do it together. Yang ni. Example ni. I will show you the ni, tapi you cuba buat dulu. Okay. Okay, so at 10100, which is 1, 2, 4, 8, 16. At 20, the current output is 10 milliamp. Okay, so at 0001, it will be 0.5 milliamp lah kan? Betul? So, bila dekat 11101, dia akan jadi, I akan ni, masukkan blank sheet kat sini so that I can discuss with you the solution ya. Sekejap. Sekejap saya ni. Okay, saya ambil soalan tu. One minute. Okay, I'll share with you now the soalan so that we can do it together. Okay, that is the question. Okay. Okay, so how kita akan tengok I akan pakai color lain so that you know that is the answer ya. So 10100 is equal to berapa? 1, 2, 4, 8, 16. 20 kan? 20 mana nak pakai ni? 20 of 10 lah ya. Subscribe. Kita pakai macam ni. Okay. Okay. And okay, masa itu ia memberikan kita masa 2010 dia kata sorry, for a digital input of 10100 and output current is 10 milliamp. Okay, therefore at 0001 berapa current kita? Kelas 10 milli divide by 20 will give us 0.5 milliamp. Okay, so that will be the step size. Okay, so the next question we are asked, what will I out be for digital input 111101? So at hence at 11101, okay, this is equal to what digital? 1, 2, 4, 8, 16. 16, 8, 24. 24 plus 4, 28. 28 plus 1, 29. 29. Betul lah? Kalau tak betul cakap kat saya tahu. 29, yes. 10. Betul ya? 10. So we will get 0.5 milliamp times by 29. So we will get berapa tu? 14 point berapa? Sekejap saya ambil kalkulator saya. Times 0.5, 14.5 milliamp. Okay, that's the answer. Yang lain dapat tak? For this particular. So the most important thing in any of this digital to analog conversion, okay, kita kena dapatkan di sini. Step size dia. Berapa step size dia? Maknanya bila at 1 tu berapa? Once we get berapa, kita boleh senang nak tengok yang lain tu. Okay? Any questions on this? So what if the question asks what is the full scale? What is the full scale current? Full scale maknanya masa bila? When the question asks full scale, that is during when? During semua high lah kan? That is during full scale. Full scale is bila semua input tu, there's one chat there. What? Yes, betul. Thank you. Azka, you got the answer. Good. Okay, full scale is masa semua high, which is 1111. Okay, berapa nilai dia? Semasa full scale, which is during 1, 2, 4, 8, 16. During 31 rasanya. Kan? 3110. Okay, that is actually the full scale. So bila semua high, so you will get berapa? 3110 times 0.5, sorry. 0.5 milliamp times 31, so you'll get the answer at full scale. Okay? 31, sekejap 31 times 0.5, it's 15.5 milliamp. That's the value of the full scale. Okay? Okay, ini solution untuk yang soalan yang ni. Okay. Good. Azka. maknanya you people understand. Very good. Okay, so let's proceed. Bagus. Okay, ini adalah untuk 6-bit binary. Remember, the most significant bit will have the smallest resistor, which is R. Yeah, and the least significant bit will have the highest resistor value, R, 2R, 4R, 8R, 16R, 32R. Okay, itu you kena ingat ya. Okay, ini dia. Okay, ini adalah a summing operational amplifier with a resolution of 6.25 volt. Okay, sometimes it is called step size. Sometimes it is called resolution. Okay, so ianya adalah similar parameter, which means step size resolution adalah the consistent value when your input change from one value to another. Maknanya daripada 0 ke 1, step size-nya ataupun resolution-nya adalah 0.625. Why negative here is not to show that the value is reduced, but because this is operational amplifier. I remember in your electronics you learn the operational amplifier. The inputs is actually going using the inverting inputs. Negative ni kan, inverting inputs. So the output is opposite of the input value. Bukan nilainya negatif maknanya less than 0. No, yeah, because this is inverting inputs. Okay. So sorry. So ini adalah 4 inputs. Okay. Normally for this design of the AC circuit, they will give us what is actually the resolution and they want us to design. Why resolution is the most important thing that we would like to know. We can actually, whatever it is, kita cari dulu what is the resolution, because once we know what is the resolution, okay, we can actually complete everything. Okay, sama juga di sinilah masa kita buat tadi kan, kita cari resolution dia. Maknanya resolution is at 0001 masa dia 1. Similarly here, dia bagi kita resolution adalah 0.625, which means masa the first one, 0001. And bila once kita tahu what is the resolution at 0001, kita boleh kira yang lain lah, full scale dan sebagainya. And this is actually, kalau dia kata dia tak bagi berapa nilai resistor, you can always fix your R, your most significant bit sebagai 1K. And the rest follow, 2R, 4R, 8R. And normally, but not always, okay, feedback resistor is equal to R. Normally, but not always. That one, if the questions did not give you, you can assume. Okay? Okay, this is another example. Cuba buat. Ini mana? Dia bagi resistor dekat 2 to the power of 5 sebagai 20K. So dekat berapa tu kalau 2 to the power of I? R, 2R, 4R, 8R, 16R is 20K. Okay? Tak apa, nanti you boleh try yang ni. Saya nak teruskan yang another one. Okay, kita ada 2 ya. Kita ada tadi DAC, the first DAC. Sekarang kita akan tengok the second DAC, which is kita punya R to R ladder DAC. Okay, this is R to R ladder DAC. Okay, sama bezanya tadi, that one is dia begitu kan, dia in series begitu. Yang sini dia ada 2 saja value, which is R and 2R, and it is connected to the most significant bit. Ingat the least significant bit will be connected to the 2R and 2R, and then dia terus ke ground. Okay, so which one to use and which one is better? Okay, yang first one tadi weighted resistor, kita panggil dia weighted resistor. Yang kita tengok ni adalah ladder. Okay, sebab dia macam tangga kan, dia macam ladder ni. Okay, okay, so untuk weighted resistor DAC ni, okay, when all bits is 1, branch currents are weighted sum. Okay. Untuk ladder pula, when all bits adalah A. Okay, bila dia semua di sini. Okay. Branch current are equal. Each contributes different fractions to the load current. This uses n resistor, whereas this uses 2 to the power n plus 1 resistor. Dia ada extra resistor di situ. Untuk weighted resistor, nilai resistor dia berbeza. Kalau ada 4 bit, kita memerlukan 4 different resistor, which is R, 2R, 4R, and 8R. While untuk resistor ladder di AC ni, we only use 2 different resistor, which is R and 2R. Okay, so in terms of matching the value, okay, weighted resistor ni mungkin ada a bit of disadvantages because it's quite challenging to match the resistor value. Whereas untuk resistor ladder ni, because it depends on only 2 values, which is R and 2R. Okay, so weighted resistor ni may be a bit challenge when it comes to IC form. Bila kita nak ni kan, while untuk ladder ni is much more easier. Feedback resistor op-amp ya, untuk weighted resistor normally is 0.5 R. Itu dia punya, we can assume that. And untuk resistor ladder normally is 3R. 3R tu di sinilah feedback resistornya ataupun 2R. Okay, so that's the comparison between weighted resistor and kita punya resistor ladder. Okay, any questions before we go to the AC specification? Okay, so far. Let's take a 3 minutes break, boleh? And we will continue. Kita break 3 minutes.
Yes, ma'am. Okay.
Meanwhile, if there's anything that you would like to ask, nanti boleh tanya ya. Bila kita mula balik. Okey, kita sambung semua. Saya makan sikit lapar. Pagi-pagi tak boleh nak makan.
Ya, Prof.
Dah makan sikit dah. Makan. Sekejap ya. Saya sambung balik, sorry. Ambil air tadi. Wait. Batuk sikit lah saya. Tapi dah okey lah, dah recover. Okay. Okay, so sebelum kita untuk yang digital to analog conversion ya, the things that you need to ensure, macam tadi I have mentioned to you students, is the resolution. That is the main information that we require, yeah. Because once we know the resolution, so what is resolution? Dia ada macam-macam definition dia bagi resolution, step size dan sebagainya. The smallest change is actually the change that happen when the analog input and the analog output, based on the change in the digital input section. So this is one way on how we can compute our resolution, full scale dia berapa, lepas tu kita bahagi dengan 2 to the power n minus 1 lah. Kalau 4 bit kita bagi dengan 15 lah, 2 ganda 4, 16, 1, 15. Kalau 5 bit tadi, that's why kita bagi dengan 31, so that kita tahu resolution, because with the resolution, the rest we can compute, we can calculate actually. And also the percentage resolution, which is the step size divide by the full scale times by 100%. Okay, selain daripada tu, lepas kita dapat resolution, we can compute the accuracy. So what is accuracy? Is the full scale error, kalau ada, if any. So ideally, kalau theoretically we never go for this, but if you go to your labs here and you start measure the step size, akan ada sedikit lah. Dia tak adalah as perfect as kita compute theoretically. Dia akan ada sedikit a small minimum error which is tolerable, and also the linearity error di sini. Those are the things that you need to actually take into account and consideration when you do your design. Okay, so kita dah tengok di AC ada 2 circuit weighted resistor dan ladder, R2R ladder. Sekarang kita akan tengok analog to digital conversion. So those are the 2 circuits. Actually ada circuits lain, tapi the common one yang 2 ni lah. The common digital to analog conversion is the 2 circuits that we have shared. Now we are going to look at analog to digital converter. Okay, which is inputs kita analog, kita nak convert kepada digital. Yang tadi inputnya digital, kita nak convert kepada analog. Okay, so analog to digital converter adalah digital code that represents the analog input, okay, and generally more complex and time consuming as compared to DAC. I don't know why the circuit lari lah. Dia punya ayat ni lari. Consuming. No, dia tak cukup okay. So kita akan tengok hari ini ada SAC dan sebagainya, dan selalunya kita akan guna operational amplifier sebagai comparator untuk analog to digital conversion. Okay, this is the first one yang kita akan tengok, which is the digital RAM analog to digital converter. Okay, so macam mana ia berfungsi Okay, dia di sini. In any analog to digital converter, dia ada one small portion of DAC, digital to analog converter, which is yang warna biru ni kalau you tengok. Okay, yang shaded in blue color ni. That is where yang tadi kita belajar tu. Either the weighted resistor or the R2R ladder ada dekat di situ. Okay, so how the performance is actually being done. Let's say we have from the name is analog to digital converter, meaning kita nak convert the analog signal, the analog signal to its digital equivalent. Okay, and it is being done by circuit, by this circuit. One of the circuit that can do is this digital RAM. Okay, so the process bukanlah is very slow macam mana saya nak explain dekat you nanti, but in order for us to actually understand how the process is being implemented, okay, so you kena bear sikit lah cara saya explain ya. Okay, so these are the whole circuit is known as analog to digital converter. What it is doing, it is converting the analog signal which is input here, VA, V analog, and hasilnya final adalah di sini, digital results ni. Okay, selagi conversion belum complete, okay, the process continues until it converts to the digital equivalent. And in the analog to digital converter ada juga digital circuit di dalamnya. Okay, so let's say the first thing adalah VA. Okay, di sini kita menggunakan several components, which is we have counter, we have operational amplifier as comparator because it's going to compare the two values ya. And kita ada juga AND gate di sini, maknanya bila tiga-tiga ini high and sini low ya, sebab sini 0 baru dia akan aktif. Okay, baru clock ni akan counter naik satu. Macam tu. Okay, so selagi VAX ni, VAX lebih besar daripada VA, proses itu akan continuous until VA adalah lebih besar atau sama dengan VAX, baru dia akan tunjuk what is the digital results. Okay, katakan you ada di sini 5. Okay, so bila mula-mula 5, okay, dia akan compare, mula-mula dia start dengan kosong. 5 and 0, 5 is greater. So dia akan continue, counter akan naik, okay. So the sini akan keluar, bila counter naik satu, this one will be 0001. Okay, 0001 dia belum tukar lagi. 5 ini saya bagi a very simple example. 5. It should be 0101. 5 lah. Kita convert kepada digital. Okay. So dia akan naik. So dia compare balik. 5 and 1. Okay, 5 and 1. Kita ambil step size sebagai 1 volt lah sebab to explain to you. 5 and 1, okay, it continues again. So now this becomes 2. You compare 5 and 2. Okay, so analog masih besar, the process continue, counter akan naik, dia akan jadi 3 sehingga 5 is equal to 5, baru counter tu akan stop. Why? Because 5 and 5 dia dah sama. Okay, bila sama di sini, okay, dan dia akan compare di sini end of conversion because dia dah sama, end of conversion because dah sama. Di syarat dia comparator ni, bila V analog is greater or equals to VAX, end of conversion stop. Bila stop, salah satu AND gate ni low, counter dah tak boleh aktif. Why? Because remember AND gate, salah satu sahaja low, dia akan tidak akan memberikan output high. So bila output sini low, clock akan stop. So the last conversion tadi adalah 5, which is 101. So that represent, okay, that represent the analog value to be converted, which is 101. Okay, that is how the conversion is being done using digital RAM. Sini ada ayat-ayat dia lah, tapi saya explain dekat you tadi kat situ. Okay, so that's how actually the process of conversion happens. Okay, you will get the notes here untuk you strengthen your ni, jangan risau. Okay, so you don't memorize the sentences, yeah, but we need to actually understand how actually the process goes and how the conversion is being done. Okay, so the thing that you need to actually understand is what controls what is here. as long as VA is greater than VAX here, okay, the process continue until and unless VA is equal, okay, only then it stops. Because one end of conversion stops, the AND gate will not function anymore and the clock will not be triggered, counter will stop increasing. Whatever the last value being stored in the counter prior to before this is active, that is actually the value of digital being converted for this respective analog voltage. Okay, everything is actually explained here. Okay, but I don't want to read it to you. I want you to actually faham cara kita explain how the conversion is being done. Okay. Okay. Ini ada satu soalan di sini. Kita biar dulu, ya. Kita tengok another one which is SAC, successive approximation. Sorry. Analog to digital converter. 1 minit ya. Okay. So the second one is actually successive approximation ADC. This is actually the most widely used analog to digital converter. Not to say it is complex, pada saya dia lagi mudah sebab dia adalah the conversion time adalah shorter, ya. And also SAC are also available in IC. Okay, this is actually the circuit of SAC. Sekejap Oh dia tak apa. Dia memang begitu. Okay. Sorry. Okay, kalau SAC, sorry. The input voltage ni juga adalah the analog voltage that we want to actually convert. And it is again being compared with this operational amplifier that functions as comparator. Okay, so apa yang penting di sini untuk SAC, dia punya digital to analog converter. Remember, in every ADC dia ada DAC dia. Kita perlu tahu dia ada berapa bilangan bit. Okay, bagaimana the conversion is being done? Okay, first dia akan start dengan kata kalau ada 4 bits, okay, dia akan start dengan MSB set to 1. So kalau 4 bits kita akan ada 1 0 0 0. Okay, so dia akan compare. Kata yang masuk situ 5 volt. 1 0 0 0 adalah 8. So input voltage analog 5 compared dengan DAC, VDAC ni 8, of course Vin is less. So yang set MSB tu kita initialize kepada 0 and next MSB, okay, next MSB set to 1. So sekarang dia akan jadi 0 1 0 0, which is 4. 5 and 4 V input lagi tinggi. Okay, so remain the bit and then set next bit to 1. So dia akan jadi 0 1 1 0. Dah jadi 6. Okay, Vin dengan 6, Vin lagi rendah, so reset. So dia akan jadi 0 1 0 1, which is 5. So 5 and 5, that is actually the conversion. So the final value dalam BAC ni is 0101, which is digital, that represents the analog value, which is 5 volt. The results will be sent to the output here. Okay, So memang pening sikit nak faham, saya faham sebab you baru tengok. But this is actually the flow chart, okay? Kita set dengan MSB bit tu duluan dan kita teruskan, ya? The explanation is here. Process 3 and 4 repeats ya until all the bits have a value, and then kita lash out dia punya value. Kita lash out di sini. Okay, that is SAC. Okay, this is the circuit of the SAC. And the third one yang kita akan tengok adalah flash ADC. Okay, flash ADC ni dia adalah sangat mudah sebab dia it's like a flash lah, dia convert sekali, cuma dia ada disadvantage dia lah yang kita akan tengok kemudian selepas ini. Okay, it's actually a high speed conversion. Okay, even though the circuitry is a bit complex because the number of analog comparator tu bertambah. Okay, that depends on the number of bits, yeah. Okay, so as the number of bits increase, the number of analog comparators juga will increase. So kat situ dia punya disadvantages lah ya, dan menyebabkan the circuitry being more complex and bulky, lebih banyak di situ. Okay. Okay, this is one example of flash ADC. Ya, so ini adalah yang menggunakan priority encoder dan di sini adalah dia punya analog comparator. So kalau untuk berapa bits yang ini, let me check, 1, 2, 3, 4, 5, 6, 7. Untuk 7 bits, of course for each bits we need each comparator, each analog comparator di sini ya. Dan dia punya voltage di sini adalah menggunakan voltage divider. Okay, so kalau 7 bits, okay, menggunakan voltage divider, so that's how this 1 volt, 2 volt dan sebagainya, the values are there. Okay, dan ia mengeluarkan the MSB based on the priority encoder. So kalau the analog inputs yang masuk from here, from the bottom up here, dia akan compare serentak all. Let's say we have 1.5. Okay, what happened? 1.5, dia akan compare 1.5 and 1. Okay, 1.5 and 1 will give C1 a 0. Maknanya because this is active low ya. Selainnya dia akan bagi output C2 dan sebagainya sebagai high, because this is because 1.5 and 2 lagi tinggi, 1.5 and 3 lagi tinggi dan seterusnya. Ada one condition sahaja, 1.5 lagi rendah. Sorry, 1.5 the analog voltage lagi tinggi daripada the voltage being compared. So 1.5 and 1, okay, only one situations that C1 will be low, selainnya C2, C3 semua akan high if the input is 1.5. If we say 6.5, 1, 2, 3, 4, 5, 6. The first 6 will be active low, we will be active which is low, hanya satu saja akan disable which is 1. So kalau 6.5, wait ya. I bawa sini sikit. Tak nampak. Okay. Okay, kalau 6.5, okay, it will show us di sini, the second last row. 6.5, okay, it will give us 110. Okay, and this is priority encoder. It doesn't matter what is the value of other inputs, it will focus on the last inputs which is C6. Okay, that is the 3 analog to digital conversion, which is digital RAM, successive approximation, dan flash ADC. Okay, and again untuk DAC juga, analog to digital conversion, kita akan tahu juga, kita nak tahu juga all the resolution and accuracy. Ya, supaya kita boleh compute all the full scale dan sebagainya. Okay, and the conversion time as well. So kalau tengok conversion time ya, how do we compute the conversion time untuk digital RAM? Okay, dia bergantung kepada number of inputs dia. Oh sorry, number of bits dia. Kalau untuk flash dia sekali je, one go dia compare terus. Kalau untuk SAC dia bergantung kepada number of size of SAC punya DAC tu. Sebab dia kena set MSB tu satu-satu kena test kan. Kalau 4 bit 4 kali lah. Ya. Itu macam mana nak tengok conversion time. So kalau yang okay sebenarnya adalah flash lah, sebab at one instance dia convert terus. Cuma the circuit is a bit complex, yeah, and bulky. Okay, any questions? Mahasiswa, mahasiswi. I hope you can bear with me.
Ada pertanyaan mungkin silakan.
Mungkin segan mau cakap tu.
Ya, dicoba say in English.
Tak apa.
Ya, Prof Noorita juga paham kalau ada kekeliruan. Beliau juga ngerti bahasa Indonesia.
Boleh, boleh. Saya faham insya-Allah. Ada apa-apa? Because I think we are already towards the end dah. Dah tak banyak dah. Maybe that anything that you would like me to add or explain lagi ke? As a preparation for your final exam. Kali ni final exam face to face ya, Prof?
There is two type exam. Maybe in laboratorium examination we should practicum.
Oh.
Yeah, and the second is theory examination. They can answer in by online or by face to face.
Okay. Understand. One minute ya, I tunggu dia feedback. Tak ada, okay. Everything macam okay saja. Okay, I will try to get some questions. Hold on ya. To share with them. Wait 1 minute. Okay, I give you your 3 minutes break sekejap. Pergi buat kopi ke apa. Saya cari soalan. I just want to share kalau ada soalan yang exam punya dari sini. Kalau ada lah. Sekejap digital. This is actually which semester, ya, Prof? These kids, this mahasiswa.
Yeah, yeah.
This mahasiswa is in which year? Final year or second year, like that?
Second year.
Second year. Okay. Yeah. They will be coming back lah, ya.
Yeah.
1 minute. Pula. Mostly is on. I think I will share. I think I can actually share with them the something on flip flop if they want to know more. Kan? Any questions on your part before kita cuba buat satu soalan yang tadi ada saya share tu, yang saya tak completekan tu sebab sekejap saya tengok soalan. Saya nak cari soalan exam tak jumpa lah pula. The soft copy. Or at least can give you some idea what will be the questions on our part kan. Meanwhile, if you have questions on your part, maybe we can share. Saya tengok soalan yang ada di sini. Any questions from your part, class? Okay, ada di sini sekejap. Ini senang saja. Sebentar ya. Okay, compute, I give you one question. Compute the conversion time for bit ABC using SAC and flash converter with frequency 1 megahertz. 1 megahertz. Okay, let's try and do this conversion time. Yeah, wait 1 minute. Okay, cuba buat ni. Compute the conversion time for a 4-bit ADC. Kita nak convert analog to digital with frequency 1 megahertz using digital RAM, SAC dengan flash converter. Okay, remember digital RAM tadi dia bergantung kepada it's a 4-bit lah, dia dah bagi tahu kat situ 4-bit. So you boleh tahulah berapa di situ, ya. SAC and flash converter. You cuba buat dulu. Nanti saya akan bantu untuk tunjuk solution. Okay, so sekejap so digital RAM, remember kalau 4 bits dia akan go 1 by 1 kan, so it will be 2 to the power of n minus 1. So kalau 4 bits dia akan proses tu sebanyak 15 times. Kalau digital RAM. Kalau SAC 4 bits dia akan test the bits 4 kali. Dan flash converter 1 go. So T conversion time, okay. Conversion time okay. Kalau untuk RAM dia akan jadi 1 over F, okay. T is 1 over F times 15. Sebab dia akan proses sehingga 15 kali lah kan. Sampai dia dapat. Okay. Kalau untuk SAC, it will be 1 over F times 4 because it's 4 bits. Okay. Ini you compute. You masukkan F to 1 megahertz. Dan kalau untuk, this is untuk SAC. Sorry. Okay. Dan kalau untuk flash ya. Dia terus 1 off saja. Dia sekali serentak dia compare. So which is 1 over F. Okay? That is the computation untuk conversion time. So dekat sini kita boleh nampak lah flash converter is the one doing very fast. The only challenge is because flash converter ni dia punya circuits is very bulky because as the number of conversion increase, okay, the larger the circuit because the number of analog comparator is being actually compute, yeah. Okay. Any questions on that, mahasiswa? Or if you would like to ask me anything. Student. So far so good. Bagaimana? Okay, kalau sebentar ya, kalau tak ada. Okay, Prof, kalau tak ada, saya rasa saya boleh bagi pop quiz lah, Prof ya. Saya
Ya,
dah,
ya,
saya dah,
Prof. Ya.
saya dah siapkan. Okay, so kita ada lagi lebih kurang 20 minutes. Boleh lah ya?
Ya, Prof.
Okay. So the link ada di situ, mula-mula jawab lah anak-anak.
Link ada di chat. Silakan mulai.
Boleh lah. Sila. All the best everyone. Boleh mula sekarang. Saya telah share link di situ. The link needs permission. 1 minute, 1 minute. I will allow. Maybe I tak keluarkan tadi kot. 1 minute ya. Okay, try now. Dah boleh ke? Saya dah allow dah, sorry. Muhtar, dah boleh ke? Azkar, I dah allow dah. Can you do it now? Sorry, I patut bagi tadi. Okay, thank you. Okay, boleh mula. Sorry ya. Okay, good. Siapa yang dah sudah, okay. But siapa yang belum ada masa lagi, you still have time. Yang masih buat, you have another like 7 minutes ya. Sorry, saya terkeluar tadi. Baru ada berapa yang respon? 1, 2, 3, 4, 5, 6, 7, 8. Baru ada 8 responses. Sila yang lain. Sebelas ya, baru 11, belum lagi siap. Tak apa, saya tunggu, saya bagi masa lagi, ada masa lagi. Sebab quiz ni saya tak bagi totally on multiple choice lah, ada setengah tu short answer. Okay. Please try ya, mahasiswa-mahasiswi semua, jangan tak cuba. Because ada 66 ni online. It's good to test actually whether you understand or not what we have been sharing for the last 3 sessions, yeah. Because when we attempt questions, that is how we know whether we understand or not. So masih ada ramai yang belum hantar. Cuba buat 18 orang, very good. Silakan 19. Ada masa lagi, saya bagi sampai pukul 11, sampai pukul 10 di sana. Sini pukul 11. Ada lagi 6 minit pukul 10. Boleh habiskan. We have 29 responses. Ada lagi 3 minit, everyone. Cuba ya. Okay, we have 41 already. Very good. Sikit lagi. 42. Please finalize your answer. Kita ada lagi 2 minutes. Okay, we have already 45 of you. Ada lagi 20 macam tu belum settle. Mungkin boleh settlekan lagi 1 minit, 2 minit insyaAllah. Because lagi 2-3 minit saya akan stop accept responses. Okay, tapi saya akan bagi peluang lah. Sila settlekan ya. Prof, 1 more minute, okay ya Prof ya?
Ya Prof, ya silakan.
Lagi 1 minit ya.
Ya silakan.
Kasih peluang dekat anak-anak jawab.
Ya Prof.